Okay, let's talk about simple logic element NOT. We can use for assemble NOT element, we can use one NPN transistor, maybe PNP2, and in the same time we can assemble this simple logic element NOT by using one NAND element. This is our NAND element. Each NAND element solves in microschemes. For this we will use microscheme 4011, and this microscheme have blah blah like this 4011, and we have 14 pins, and we connect. By the way, we connect first and second pins and give with our switch to pins high and low voltage, and the third switch we will connect to the LED for see how indicates our element. Let's draw this in simple like this. It's our NAND element. We connect inputs our NAND element together, and output we connect to the LED. This is our output. Ground. Let's starts indicate when we give a low voltage. It means that when we give input low voltage by this switch, low voltage, our LED starts indicate when we have input high voltage, and when we give high voltage to the input of NAND element, we have low voltage in output. It's our simple NOR element in real scheme. This is our micro scheme 4011, and we connect both of our inputs between we connect both of our inputs to each other and connect it to the switch. It's our switch, and we connect our switch to our switch LED for indicating when we give high voltage. When we press button of our switch, then our LED starts light, and we understand that we have high voltage in input. Now we see that we have low voltage because our first LED switch LED not lights, and in output in this LED we have light. It means that we have in output high voltage. We see that through table of NOT element. When we give input and we have output, when we have 1 we have 0, when we have 0 we have 1. Yes, and when we now we have 0 in input, and in output we have 1. And let's give high voltage to output. We see that when we give high voltage to output, our LED start light, and our output have low voltage. And when we give low voltage in output, we have high voltage. This is work of simple NOR logic gate, not logic gate. That's all.